Hello, this is Mike here, and in this video we're going to be advancing our ability to solve radical equations. And in our past video series, we've worked with some radical equations that all have indices that are 2, which means that there are square roots. But notice in this example, we're working with a radical equation that has an index of 4. And notice our radicand also is no longer a linear radicand, it's a quadratic. So first thing we can go about a couple different ways is that I'm going to go ahead and rewrite this problem as x squared minus 1. I'm going to convert that fourth root into a rational exponent, which is a value of 1/4. So we're going to rewrite it like that. Hopefully it'll make it a little bit easier for you to see about the counteracting operation we're going to use in order to get rid of that fourth root. But I'm going to go ahead and talk about the domain of this problem, and notice here we're going to have x squared minus 1. This guy must be greater than or equal to 0, and we still hold this restriction because the index is even. And if the index is even, we can never have a negative radicand, so we know it always must be positive. So now we're looking at where is x squared minus 1 greater than or equal to 0. I just don't want to have to solve this now. We can solve it. I always recommend doing it graphically, and we recommend here that we're going to have zeros at -1 and +1, and we have to figure out where this thing is positive. So it's positive from -infinity until -1, and then 1 to +infinity. But I do not want to have to worry about doing that in a problem that's just stating to solve a radical. So that's the reason why I always recommend to plug in at the very end to make sure your answer is correct. So in order for us to counteract that fourth root or the 1/4 exponent, we're going to have to raise everything to the 4th power. So we're going to have x squared minus 1 all to the 1/4, and we're going to raise this all to the 4th power. But whatever I do on the left side, I have to do on the right side. And this is actually pretty nice because 1 to the 4th just gives you a value of 1. So on my left side, I'm going to have x squared minus 1 because here the 1/4 and the 4 cancel, and we get a value of 1. And this equals to a value of 1 to the 4th power, which is a value of 1. So here I'm going to add 1 on both sides. And notice this gives me x squared. X squared gives me a value of 2. But remember, when I solve this and I take the square root of both sides, I have to add a plus or a minus there. So this implies that x equals to plus or minus square root of 2. So I always recommend, and I think it's important and a necessity to plug in at the very end. So let's go ahead and plug in our first solution. So we're going to have the fourth root of positive square root of 2 squared minus 1. The square root of 2 squared cancels, so we're going to have the fourth root of 2 minus 1, which gives me the fourth root of 1, and that equals to a value of 1, which is what we expected. So that's a check for the positive square root of 2. So that one's a check for the positive square root of 2. So now when I plug in the negative square root of 2, I'm going to do so using a set of parentheses. And I square that. And when I square a negative, it's going to be a value that's positive. So we're going to get the exact same thing. So I recognize that both of these answers will be sufficient and they will not violate the problem. So we know x will equal to positive square root of 2 and x will equal to negative square roots of 2. So let's go ahead and advance to a problem that's a little bit different. And in this problem, we're going to have two different radicals. So in this problem, we're going to have two different radicals. So how do we solve this, or how do we work with this? Yes, we could start off with identifying the domain. That's just a little complex. I don't want to look at the intersection of the two domains. I just want to go ahead and solve and plug in. So the first step that I recommend is to isolate one radical. So if we isolate one radical, we're going to get the other radical on the opposite side of the equation. So does it matter which radical we choose? Absolutely not. So notice here, this will cancel with this, and we're left with the square root of x minus 3 equals to 5 minus the square root of x plus 2. So we've isolated one radical to one side of the equation, and now we must perform the opposite property. The opposite of the square root is to square, but we have to do it to the entire right side. So we're going to do this to the entire right side. So I'm going to put a little star here to make sure that we FOIL this right side out, because in essence we have a binomial. So do not think you can distribute the square, because that does not work. You have to actually multiply that out twice. So on the left side, the square root of x minus 3 squared is going to cancel. We're left with x minus 3. I notice I moved my problem slightly over to the left just because I know it's going to take a little bit more room. And I'm going to expand this part out twice. So I have 5 minus square root of x minus 2 times 5 minus square root, x plus 2. So I expanded this out twice because I'm squaring it, which means I have to multiply this out twice. So now we're going to FOIL. On my left side, I'm still going to have x minus 3, and we're going to have 5 times 5, which gives me a value of 25. Next, we're going to have 5 times negative square root of x minus 2, and that's going to give me minus, because it's a negative here, it's a negative here. So we're going to have minus 5 square roots of x plus 2. Next, we're going to have negative square root of x plus 2 times a positive 5. So we're going to have minus another 5 square roots of x plus 2. And then in our last portion, let's do this in bright blue, we're going to have negative square root of x plus 2 times a negative square root of x plus 2. That negative times a negative will give me a positive. And square root of x plus 2 times square root of x plus 2, square root of x plus 2 times square root of x plus 2 is equal to the square root of x plus 2 squared. And that just equals to x plus 2. So we're going to have plus x plus 2. So now what we're going to do is that we're going to combine our similar terms on the right side. So I'm going to have x minus 3 equals to 25 plus 2 gives me a value of 27. And then I'm going to have still plus an x. So I have plus an x. And then I have minus 5 square root of x plus 2 minus 5 square root of x plus 2 gives me minus 10 square roots of x plus 2. So now the goal is to isolate. We want to isolate the second radical, because when we isolate that, we'll be able to counteract that radical by squaring it. So now we're going to get everything over to the opposite side. So I'm going to subtract x off on both sides. So notice the x and the negative x cancel. So we're left with negative 3 equals to 27. That canceled. Minus 10 square root of x plus 2. Now we're going to subtract 27 on both sides. And we get negative 30 on the left equals to the negative 27, the positive 27 canceled. We get minus 10 square roots of x plus 2. And now we're going to divide both sides by negative 10. And we're going to get positive 3 equals to square root of x plus 2. So now the radical is completely isolated. We are going to go ahead and square the right side to counteract that square root. But when we square the right side, we also have to square our left side. So we're going to get a value of 9 on the left side equals to x plus 2. And then we subtract 2 on both sides, and we get 7 equals to a value of x. So after doing all that work, we get that nice integer value of x equals to 7. But we always must check our work. So I'm going to go back up to the beginning of this problem, which was all the way up there, and we're going to plug in. So I'm going to have the square root of 7 minus 3 plus the square root of 7 plus 2. 7 minus 3 gives us 4, so I get square root of 4. 7 plus 2 gives us a value of 9, so I get square root of 4 plus square root of 9, which is equal to 2 plus 3, and that's a value of 5, and that's what we expected. So we always want to plug in. We have to plug in on these problems in order to make sure that we are correct, and in fact we are.